Hello, everybody. Welcome to our e-learning day, sort of at the last minute e-learning day here on Monday, March 9th. Maybe during the end of the session, I could take any questions that you guys might have. We're definitely going to talk about the week ahead to see what other kinds of contingency plans that we might have. But for right now, we just have a teeny bit to do. It's kind of a perfect day to do this, you guys, because we only have one example that we have to cover. So that should go pretty quickly. And as you can see in the agenda here, I can clarify any questions that you might have over the homework that was associated with 8.1. And as I said before, we'll discuss the week ahead. For those of you that are in period 3, I'm assuming that you had all finished your exams. So I will get to school. I'm allowed to get into school today, and I'm going to go ahead and get those scored for you. Hopefully tonight. Yeah, I have no reason why I can't get them done for you tonight. So we'll get those into the grade book. So again, overall, I'm really pleased with how the unit 7 looks. A little bit of issues with some of you. I want to pull some aside and talk to you, but as a whole, I think we did a good job. I'm also hoping that we had a pretty good time in class Friday. I didn't hear any good things, bad things, really. So example 1 and 2, I'm hoping made a bit of sense. I wanted to pull something in here for you guys to see. I have the solution manual here, the solution key to the problems that you guys had. That's not the solutions, is it? Let's try this again. I had pulled these in. Yeah, we'll find them. We'll find them, guys. We are going to find these things. Lecture notes. Unit 8, solutions. Okay, sorry about that, guys. Here they are. I just wanted to make sure that you guys were feeling comfortable with these things. I don't have the solution guide to the notes posted yet. They're still under construction. I'm about midway through section 8.4, 8.5. I may go ahead and post what I have, though. But just really quickly, I wanted you just to get an idea that this average value of the function formula is about as easy as you think it is. If you were looking at this thinking, wow, there's not much to this, well, there really isn't. It's your basic definite integral, right, that we've been working on many, many times before with this 1 over b minus a out in front. That's all there is to it. So I know that the video that was recorded went through these 2 solutions, and the two solutions here for A and B are consistent with that video. But if you ever needed to take a look at this, I'll get this posted up later this afternoon, and it shows the calculator screenshot here for problem 1 and those 2 particular answers. Problem 1 is not one of my favorites because of the fact that this y value is so teeny tiny. But I like the fact that it is a calculator-assisted problem to give you guys a little bit more insight with the calculator. But number 2 was a little bit more traditional. You could see the graph here and the fact that the average value of that function was going to take on a number of 16, and it was going to occur at 2 2/3, which happened to be this 8/3 right here. And the key for B is that we have to disregard this x equal -2, because just like in the mean value theorem before, -2 did not lie in this interval 1 to 4, and we don't want it. So I really hope that you felt pretty comfortable with this, because I don't want average value of a function to be a big issue. So with that, let's go ahead and let's move on to our example 3 here, which is just a little multi-part free response question entitled Got Milk? And you'll find out that it does draw upon some ideas from the previous units a bit. So we are sort of stepping into this, let's review for the AP exam mode. But when we get down to part C, it's going to utilize a question that deals with average value. So it says here, the cows, and this is a calculator active problem. It says the cows on a small dairy farm in northern Indiana are milked in the morning during a 2-hour period And milk from the cows were pumped into a storage tank, and the volume of the milk in the tank at time t is modeled by a strictly increasing twice differentiable function m. M of t is measured in gallons, t is measured in minutes. At time t equals 0, there are 300 gallons of milk in the storage tank. And it says that values of m are given in the table at selected times for t. Now, the first question is drawing upon an idea from way back. Estimate m prime of 70. Indicate the units of measure and explain the meaning of your answer in the context of the problem. So essentially what we're trying to do is we're trying to take a derivative of a table, which sounds pretty crazy, right? How do you take the derivative of a table of values? But hopefully we've realized that derivative in this class is slope, and we can find the slope anytime that we have a pair of points. Now, if we look at this time value 70, we notice that that 70 is not located exactly in our table at any point. But if it were to be placed in here, it would be certainly nestled between the 50 and 90, and it would be done so fairly equidistantly. And as I've said before, that's the kind of question that you'd see on the AP exam. So what we would say in this problem is if we wanted to find the derivative of m at 70, we could get by approximating that to be the change in the m's at 90 and at 50 divided by the difference between 90 and 50. And that's just your slope, right? From that point, we can go ahead and read the chart. 3360 would be our m of 90, and 1640 would be our m of 50. We can go ahead and subtract the 90 and the 50, of course. And why not? Let's go ahead and we'll drag the calculator in here. That's perfectly okay. It is a calculator problem. So you could go to a scratch pad here. And I don't really think that you all have to type this in along with me. This is pretty easy. If we do something a little bit more sophisticated, I might have you type it with me if you've got your calculator handy, but I'd give you enough time. But there's our 3360 minus 1640. Divide that by 40, and that would give us 43. So we have this nice, whoops, make sure I grab the right thing here. So we've got this nice integer value, 43, and that would give us a point. We just haven't done the units of measure and explained the meaning just yet. Incidentally, on the AP exam, and I'm not kidding, this is a very popular question. You're likely to see this very early on. You could earn an easy point for this, but the key is that you have to make sure that you write either this or this. In other words, you have to show what's called a difference quotient. And we've had this conversation before. It doesn't matter which one of those two you write down, whichever one you end up simplifying to be 43, you'd get credit. And in fact, if you wrote this one and only this one, you would receive full credit for that because it serves as both the difference quotient and extracting values from the table, although it's not simplified, but you don't have to simplify. This one here, marked in purple, would not be sufficient for the answer point because it's not extracting values from the chart, right? So you're probably looking at a 2-point question here that could be very, very easy for you. Now it says to indicate the units of measure. Honestly, if you want to do that now, that's great. As long as you put it into your explanation, that would suffice. It doesn't have to be in both spots. I like to tell students to put it in both spots. So if you think about, you have gallons in the numerator of this, right? And you have minutes in the denominator, it sounds very likely that this is going to be in gallons per minute, okay? And you can say gallons of milk per minute, but you don't have to be that precise. So what is it that this problem is really saying? What is the explanation of this meaning? Well, we look at this number and we notice that it's positive. So we have to think about what does it mean for a derivative to be positive, and that would be that its parent function, right, its m function would be increasing. So we could say that the amount of milk in this storage tank is increasing. Well, let's go ahead and start with that. So we have the amount of milk in the tank is increasing. All right, now we're going to go ahead and use our number that we got, and that would be by 43 gallons per minute. So we have our noun number, we have our units, we just don't have our time, right? And if you remember, NUT, NUT is our acronym, and we're going to use this a lot in our topic tomorrow and throughout the rest of this week, in fact. So we need to say at that specific time, which was 70. And let's go ahead and make sure that we put that label with him as well. And that would take care of it. That would take care of every point that would be associated with that particular problem. All right. Let's move on to part B here. It says, use the data in the table to evaluate the definite integral of m prime of t from 0 to 20, and then use correct units, interpret the meaning in the context of the problem. So at first inspection, I know that when you look at this, it's easy to start to think, oh no, I see an integration problem. I see a table, and maybe your mind goes back to using those Riemann sum approximations. Well, that's not what we're going to do in problem B. We might do it in problem C, however, but we're not going to do that in problem B. And the reason is you want to take a very careful look at what is it that you're integrating. We're integrating m prime. We're not integrating m, which is the values in the table. So what this particular problem is testing you on is your ability to understand the fundamental theorem of calculus, and that theorem that says that the antiderivative of m prime is just m, right? This is just going to be m. But if we throw in boundaries, making this a definite integral, then we use the fundamental theorem and evaluate our m at 120, and then subtract, evaluating the m at 0. Hopefully you guys see that. So it's really not a very, excuse me, it's not a very super challenging problem, because you just have to read a pair of values from the table. And when we do that, we end up with, I believe the m of 120 is 4,250 gallons. And the m of 0 at the very beginning, 300. There was apparently 300 gallons of milk already in the storage tank, probably from milking cows yesterday, I don't know. And if we want to simplify that, we could, and we would get 3950. I think we can probably handle that without a calculator. 3,950. But once again, it does ask us to interpret the meaning within the context of the problem. So we have to take care of that. And I want to first of all talk about units with this, because it did say to use correct units. So if you look at m prime, which is basically what we just found in part A, the label of m prime was definitely, and I'm going to write this off here to the side, gallons per unit, right? We're just kind of thinking over here, or gallons per minute, sorry, gallons per minute. That was our m prime. Now notice that when we integrate that, we throw in this dt, which is another measurement of time. It's minutes, okay? And maybe I might think about this gallons per minute, writing it without the diagonal fraction bar so that you can see what's about to happen. I think most of you probably do anyway, that the minutes do indeed cancel out. So our unit is just going to be gallons. This integral symbol just means that we're adding a bunch of those representations together. Okay, so when we integrate m prime, we are going to definitely get gallons, 3,950 gallons. So in the context of the problem, what does this really mean? Well, we think of this integration as like an accumulator. We've accumulated from time 0 to time 120 this many gallons of milk. All right. So the best way to write that, there probably is many best ways, but one way that I would suggest is just start with that number, 3,950 gallons of milk have been added to the tank. Notice I'm not writing storage tank. I think tank is sufficient. But again, you have to invoke the t, the time factor. And because this is an integral problem, your time has to be some kind of an interval connotation. You have to use some precise words that denote that we're starting at time 0 and ending at time 120. And we've talked about the prepositions that you can use. During is perfectly acceptable. Over is a good preposition. My personal favorite is just the from and to. So we could say from time t equals 0 minutes to t equal 120 minutes. And that would take care of it. You could get kind of creative and say, over the 2-hour interval, and that's perfectly acceptable. I have some misgivings about that because it doesn't really specify when that 2-hour interval started. Did it start at time 0, time 20? So I'd like to stay away from that if at all possible. All right, truth be told, some years in the AP exam, they allow it, some years they don't. I don't want to take that risk. So let's try to use the from and to notation there. So, okay. So NUT, remember, the acronym is, N is kind of noun and number. The noun kind of indicates this stuff, the context of the problem, 3,950 gallons of milk or amount of milk in the tank. Okay. The N part also can mean number, which is our 43 gallons per minute, right? 3,950 gallons. And then the T stands for the time. Okay, that's your NUT. All right, for part C, I told you this was going to be pretty fast. We're already on our very last part of the problem. For part C, the directions say using a right Riemann sum. So, now we're going to have to break that stuff out, which I'll review with you. Use 4 subintervals indicated by the data in the table to approximate 1 divided by 120 of times the integration of m of t from 0 to 120, and then explain the meaning of this expression in the context of the problem. And does this approximation overestimate or underestimate the exact value of this integration? And explain your reasoning. Which is kind of interesting because we just had a conversation about overestimates and underestimates. In fact, that was a part of our review and getting ready for the Unit 7 exam, but this one's going to be just a little different. Now, I may have to do a little scrolling here, so I apologize. Or better yet, let's do this, you guys. Of course, you don't have to scroll because you're hopefully looking at your notes packet, but if I just do a little snip, I'm going to copy this and paste it down here, and we don't have to worry about moving back and forth. All right, so there's our table. So right Riemann sum. Okay, show of hands. How many people forgot this? Right? No, don't worry about it. We'll take care of that. It does ask that we do this with 4 subintervals, and the beautiful thing about that is that 4 subintervals is very conducive to this question. You can kind of see that if we go from 0 to 20, 20 to 50, 50 to 90, 90 to 120, we have our 4 subintervals. So it's almost like we're building our rectangles as such, and we then focus on the right aspect, the right side, which just simply means these are the 4 numbers that would be used to comprise our heights of our rectangles, okay? If this problem said to use a left Riemann sum approximation, then we could slide all of these yellow things to the left, and basically this would be what we would be looking at. That didn't work real well, did it? Sorry. So anyhow, we would use 300 all the way up to 3360 if it was a left Riemann sum, okay? So to build this Riemann sum, I also notice that there is a 1 over 120 in front of the integral. So I'm going to make sure that I plop that down just so I don't lose track of it. And then I'll remember that area of a rectangle would be the width, and the width of our first rectangle would certainly be 20, and then its height would be 780. And then I move on to the next rectangle, which has a width that is not 20, as you can see, because the difference between 20 and 50 is now 30, and that would be multiplied by the 1640. How about I make this look a little bit more like a 30? And then if I do the next rectangle, the width is 40. Multiply that by 3360. And then my final rectangle has a width of 30. And that would be multiplied by 4250. Okay. I'm going to assume that you all know how to use a calculator here, right? I think you're going to be fine if I don't manually type these in and show you what it looks like. Just be really careful. I do know that the contents of the brackets turns out to be a very large number. It's 326,700. That's probably not too hard to believe. And I wanted to isolate that just for a conversation purpose. It would not be required that you find that specific value and write it down. If you did all of this calculation at once, divided by the 120 all at once, that's perfectly acceptable. That answer turns out to be 2722.5. Okay, so the calculator would give us that. Now, we have to think about the units on this problem. And we also have to think about really what is it that this problem is asking. So if we go back and we just focus on that integral, not so much the 1 over 120, but if we integrate m of t, okay, now remember what that means is we're taking something that's measured in gallons, right? We're taking something that's measured in gallons, and we are essentially adding up all of these gallons, and at the end of that, we're dividing by 120. We're dividing by 120. So we think about what does that actually say to us? Let me rewrite this. I think this is going to help you guys. I think that helped when I did this off to the side a moment ago. So here's the m of t label, gallons, right? That takes care of the m of t. Now, let's keep in mind, we have a dt after that, and dt is measured in minutes. Now, this is crazy. This is a very weird unit of measure, gallon minutes. Gallon times minutes. Perhaps it does mean something. We're not going to get into what it means right now. It's not really something that we're going to talk about in AB. But then we also out in front have this 120, which is certainly measured in minutes. So if we divide all of this by minutes, we find that our label is back to gallons. Right? But that doesn't necessarily tell us what this means. Well, if we look at this as recognizing it as 1 over b minus a times the integration from a to b of some function, in this case that function is m, then we have what's called the average value of a function. Okay, what is this function about? Well, it's the gallons of milk in a storage tank. So the average value of that is just really the average number of gallons. So that's how you'd want to express this. So you'd say that this is the average number of gallons you might want to say of what item of milk in the tank, and then we got to put our time unit in here. So that would be from t equals 0 minutes to t equal 120 minutes. All right. Now, if you look at this from a dynamic perspective, picture yourself in this northern Indiana, milk, farm, this dairy farm, and you're seeing all of these cows and they're being milked, and that's very likely that they're being milked through these, these machines. And what's going on during this 2-hour period of time is that tank is filling up with milk, right? It starts out with only 300 gallons, but then it keeps accumulating milk, more and more and more and more. And it gets to a point where there's now 3,950 gallons that have been added to it. And we look at this as that, okay, at any moment, at any specific second of time, we could figure out, over the long haul, the average number of gallons in that milk, or of milk in that tank, would be that 2,722. And you know what? I never did say that in my explanation. It's kind of funny how I sort of tailed off there. I said the average number of gallons of milk in the tank, maybe I should add that, is 2,722.5 gallons. Sorry if you guys have to erase, but that's kind of part of the in the nut, getting that number in there. So I hope that makes sense to you guys. This is going to get on our radar really fast. Anytime that you see the 1 over b minus a, right, and it's clear that your b is 120 and your a is 0, if that thing is sitting out in front of an integral, you will immediately have the words average value in your head. And sometimes this goes two directions. There could be problems that ask you to find the average value of something, and you have to remember to toss in that 1 over b minus a in front, right? Even if it's a story problem, a contextual problem. And we'll see some more of those in our practice. All right. Essentially, this is it. This is all I needed for you guys in terms of just the notes and so forth. I am going to help those of you who had some questions with the skill builder, but I want to talk just really quickly about the week ahead here. Having trouble bringing in some of these documents. So here's your timeline. I'm going to slide that over. Hopefully you got a hold of this timeline in class on Friday. That would be awesome if the sub did that. And one of the things about this timeline that I know that a lot of students have already asked me about is, hey, there's no quizzes. That doesn't mean that we don't have quizzes. We just don't have them scheduled because Mr. Meunier have to sit down and kind of talk about how we're going to lump some of these together. So fear not, I promise you there's not a quiz the next day that you walk into class. It's very likely that 8.1 and 8.2 will be glopped together as a single quiz, and we may even do the same with 8.3. All right, so we're not quite sure yet, which obviously addresses the whole how many quizzes do we have for the semester and how does that affect the quiz drop procedure. Bear with me, guys. I promise we're going to be fair. Just keep doing Khan Academy and things will work out. Khan Academy assignments aren't officially released to you yet for Unit 8, but I will do that this evening in case you want to get an early start on those. All right, but we're almost done. We're getting very close to finishing it. So that kind of tells you what's going on in the week ahead. Hopefully, we'll touch base and we'll be able to figure out those dates for you. As far as questions about, the e-learning day, why, I'm sure that you are aware now of the student at Hickory who had been tested and diagnosed with COVID-19 and so forth. So it's very likely that things could turn back to normal and we're all back to school at all of our buildings besides Hickory. But you guys, you never know. I mean, I want you to be aware of the fact that I think that we are all safe. I don't think anybody should be like worrying about their state of health from the standpoint of mortality. This virus, it's a bad flu, right? And nobody wants the flu. And what makes this virus so scary is that it's really contagious. It was really interesting, my trip to California. A lot of their schools are closed today because of the schools being deep cleaned. They're having an e-learning day, but they're planning to return tomorrow. So it's just a matter of trying to keep kids from contacting this so that they just don't get sick. I know that there have been mortalities, fatalities with this, but that population is predominantly people that are very much at risk anyway, maybe from the normal flu. All right, but I don't want any of you to get sick. I don't want to get sick myself either. So we're going to definitely make the right decisions. But thank goodness we have Zoom. I think Zoom is a great way to take care of these kinds of issues. So I'm going to read the chat here because I'm fearful. Did I write a number wrong? 27. I'm getting a lot of chat love here. 2722.5. Let's see, Johannes. It is more favorable to put 227.2.5 at the end of your statement or after stating the units. You know what? You could do it either way, Johannes. I don't think there is any sort of favorable way to do it. As long as those elements are in your solution, in your written explanation, I think that you're going to be okay. Okay, and I know that we did not do the overestimate, underestimate, so I wanted to talk about that here just really quickly. Does this approximation overestimate or underestimate? Well, the situation going on here, we're going to have to kind of recall, this has been a while, but if you think about what this thing looks like graphically, I don't know what the graph of M is going to look like, right? Other than the fact that it says that the values in this table were, what did it say at the very beginning? Strictly increasing. See, that's your big clue. The fact that these values were strictly increasing meant that maybe this graph looks like this. So that means that if we were partitioning this off into our rectangular segments and doing so with a right side endpoint, we would cap these rectangles going to the left, which pretty clearly indicates that we have an overestimate, right? So we'll say that this is an overestimate. Of course, it wants the reason for that. And the reason is just real simple. And that's because the function m of t is increasing. And on the AP exam, that would be acceptable. I would accept that. Now, sometimes students will say, and we used a right Riemann sum. Well, that's great as well, but we know that you used a right Riemann sum. It says that in the text of the problem. But if you recall, increasing with right Riemanns means overestimate. Increasing with left would be an underestimate. Now, decreasing is just the opposite with right and left Riemann sums. So the thing I wanted to point out with this, you guys, is that whenever you determine overestimates, underestimates for a Riemann sum, it's all tied to whether the function increases or decreases. But if you recall the overestimate, underestimate talk with differential equation solutions, that's tied to concavity, the second derivative. And the AP exam will oftentimes ask you both of those. So we'll have to make sure that we keep those straight. Fortunately, we have a lot of mock exam material that will allow for that to happen. All right. So I'm going to go ahead and turn the attention to some of the homework stuff now. And those of you who are watching this tape delayed, you've pretty much fulfilled your requirement. If you don't have any questions over the homework, you can click that off button and start focusing on some of your other assignments. And for those of you that are in the Zoom here live, same way. If you drop out now, no harm, no foul. I told you I wanted to keep this about 35 minutes. I think we came pretty close, but I also wanted to make sure that any of you that were a little bit confused about some of the homework, that we take care of that as well. So popping up the homework assignment, hopefully this is what it looks like, right? The question that I had was problem 6 or 7, where it uses a graph and a piecewise function for the average value. This was asked by Emily. So Emily, make sure that this is the ones that you are interested in. So we'll take a look at number 6, I guess, if that's okay. I do not have, obviously, homework solutions posted. My thought process is I'm probably going to have the key posted first. The reasoning is because of a lot of people that are going to be out with field trips and such, and this is going to be sort of their way of not getting too far behind, because I always know that if you have homework questions, we can always take care of them. If not in class, you guys swinging by in the morning, I'll show you a solution. But basically, my whole agenda tonight is going to be to continue to work on these keys and try to get as much of it posted as possible. All right, so for problem 6, it says to answer each of these using the average value of a function. So it says find the average value of the function f whose graph is shown. So what we'll have to do here is put together our formula. If you want really cool notation, I suppose you could do this, but it's not required. But f with a subscript of average kind of indicates average value of function f. And because our interval goes from 0 to 8, we would then take 1 over 8 minus 0, right? That's the 1 over b minus a. And then we would integrate that function, f of t, with respect to t, from 0 up to 8. Okay? Now, if I don't give you the full solution here, I at least want to get you guys started. And then if anybody is like, I still don't understand, I still need more help, just give me a holler. But at the beginning of this integral, it's obviously 1 over 8. And then you have to figure out, whoa, how do you integrate a graph? Well, you have to cross your fingers and hope that the graph is very friendly. And this graph is friendly. And by that, I mean that it consists of just line segments. Remember how sometimes we could throw in a semicircle and you guys would be okay? But this should be pretty manageable, because all you're going to do is find the area between the graph and the x-axis all the way up to 8. Okay, now you might have to use some very clever geometry, and it's very acceptable to split this apart into how many ever shapes that you feel like will help you. For example, triangle is not too bad. I don't know, guys, maybe you don't like trapezoids. That's okay. You can use another triangle there. Here's a rectangle there. Another little triangle there. What would that be? A square, triangle, square. Do whatever it takes for you to be able to find the geometry there. But the key thing is to make sure that you treat the area found here as negative, right? Because of that region lying below the x-axis. That's why I kind of wrote this problem, so that we would have that nuance. So if you were to find out what all of that yellow space adds up to, you essentially would divide it by 8. And this problem has no context, so there's no units that you have to put, and there's no explanation. So Emily, let me know, does that make sense? Will you guys think you're okay to move on from that point? If I had the answer, I would tell you what it is, but like I said, I'm still kind of working on the key to the notes. So thanks, perfect. And I'll tell you what, let's go ahead and take a look at number 7, because it's a similar question in that it has like a piecewise function, because that's really what problem 6 is. It's a graphical representation of a piecewise function. But in this particular problem, you can find the average value of a function over a piecewise. Now, the way that you would do this is setting it up the same way. You would say the average value of f, if you want to write it like that, is 1 over, okay, well, what's the integral? Well, b minus a, so that would be, or the interval, 4 minus 1. And you would integrate the function f of x, starting at 1, ending at 4 with respect to x, okay? And it's no secret that the 1/3 will be simplified out in front. Now, as far as integrating a piecewise function, what you'll do with this is kind of think of this as area. All of this stuff is like the area under the graph of x squared and 2x along the proper intervals. So it might be a good idea to bust this apart and integrate each of the two pieces of your piecewise function, namely x squared and 2x, each with respect to x. But as you do that, you have to be aware that your boundaries must be modified. For instance, if x squared is only existing when x is less than or equal to 2, then we can only integrate that from 1 to 2, right? We still start with our lower boundary of 1 that we want, but we have to stop him at 2. And then the 2x, we would start integrating at 2. We just pick up where we left off, and we can take him up to 4. And then, of course, you can use that additive integral property that we talked about a couple of units ago, where if those just get added together, that result would go right here, and then you can multiply that by your 1/3. Okay, so hopefully that makes sense. I know we didn't talk a lot about definite integrals with piecewise functions, and I knew that it was going to be coming up in topic 8.1 and that we could have that conversation now. So, all right, I'm just looking here at the chat to see if any of you have any other questions about anything in the skill builder, anything in general about the week ahead. Yep, Corey, take a look at question 5. It says, on a late winter day in Avon, Indiana, the temperature in degrees Fahrenheit after 9 a.m. can be modeled by this function T of T. Find the average temperature during the period from 9 a.m. to 9 p.m. And does this problem not have a calculator icon by it? Oh, it does. Yeah, it was on the previous page. I was going to say, we got to have a calculator for this. And notice it says, use a calculator and the mean value theorem for integrals to evaluate each. But be sure to write the expression that you're typing into the calculator. That's really important, because on the AP exam, you would earn a point for expressing the thing that you're about to type in just as much as you would earn another point for the answer. So basically, T, capital T, is just a function for temperature. If you want to know what the temperature is at a certain time, you plug that T, little t in, and the big T will produce some degree Fahrenheit. All right. In fact, let's play with that for a moment. We're going to have to define this function anyway. So I'm going to drag my calculator screen in here. It's up to you if you want to follow along with me. This is nothing that you haven't done already before, at least once or twice, in terms of defining a function. So the only thing is I might need a little help here. I'm thinking there could be an issue, and I apologize for this, but on the TI Inspire, I don't think that that will be a very good idea, because even though the TI Inspire recognizes this as a capital T, as soon as we hit enter, that's going to change, and it will probably cause an issue. It doesn't understand capital letters and lowercase letters. So I'm going to call my time x in this case for the purposes of defining the function. So I have control math template to get the colon equal. And I apologize, I'm going to have to go back to the document here. 55 plus 14 sine. Okay, I should be able to remember that. So we have 55 plus 14 times the sine of, whoops, that's not going to work. Get parentheses in there first, and then I think it was pi times, and remember we're using x instead of the time t, and we have 12, and then that's going to be our definition of our function. The reason why I wanted to say this is that, hey, it's 9 a.m. right now, and I believe it says that 9 a.m. corresponds to time 0. Right? Now, it doesn't say that specifically, so you have to kind of bring that into the problem. It's just basically a beginning point that you can define. And you know what? This problem should say that, you guys. I'm going to have to go in and retype that because it should say let time t equals 0 correspond to 9 a.m. because otherwise you wouldn't know that necessarily. That could have been a lot of your issues with this. So if I wanted to figure out what the temperature was at time 3, I could just plug in a 3 and boom, it's 64.8 degrees, which kind of makes sense, right? Pretty close to what our temperature is going to be today, right? And it is a late winter day. How appropriate of a problem is it? Now, in this problem that we want to solve here, we wanted to find the average temperature. So what that means is that the average temperature is defined as 1 over B minus A. Well, if we've already established that time 0 is 9 a.m., then wouldn't time 12 be 9 p.m.? So that's what you're going to do there. Using your boundaries 0 and 12, and then there's your temperature expression. Notice you don't have to write that expression in. You can just identify it as its symbol, capital T of T. And then I'm going to go ahead and assume that you guys can finish the rest of this. In fact, I don't care. It's already typed in the calculator. Well, I want to make sure that we get an answer that makes sense. So we can go into control divide, put 1 over 12, and then multiply that by shift plus, integrate from 0 to 12. And the cool thing is we've already got our t function. Remember, I called it t of x. All right. Now, I want to show you this because if we hit enter, we could get something unusual. We could get something pleasant. Okay, I would call that unusual. That's not the way that we would communicate temperatures, right? So again, it's probably prudent that you put a decimal point in one of these values so that it does give you the decimal output. So, and that's a good answer, 63 point, I guess we better go ahead and round it, 913. I know that that's pretty precise when it comes to temperature, but this thing did not say to round, and I don't want to take any chances with that, you guys. So on that particular day, over those 12 hours, at any given moment, we could expect that the average temperature might be 63.9. If you take every temperature that we had, infinitely many, right? Because there's infinitely many moments in that 12-hour period, and divide the sum of all those temperatures by infinity, you would come up with 63.9. That's why this is pretty cool. Calculus is pretty cool. So, all right. Blake had asked about question 9. Will it not factor? Yikes. I thought it did, but it's possible that it doesn't. Find all the numbers b such that the average value of this is equal to 3. I'd tell you what, if it doesn't factor, I think you probably are going to be using quad formula for that. And this is a non-calculator question, I believe, right? So let's go ahead and use that as the approach, and I'll I'll see if I can get a key going to this so that you know by the middle of the week at least what the idea was. But after I look at that pretty closely, I think you may have to use quad formula. So yeah, good question. So, all right, appreciate you guys, all of your patience and your nice comments about the Zoom, but thought it was a great way to do this, so. All right, so I'll tell you what, I'm gonna go ahead and shut this down. I'm gonna get this processed so I can get it recorded for the rest of the students, and then I'm gonna move on and do a Calc BC Zoom session at 1:30 for those kids. So you guys enjoy your e-learning day. I'm assuming that we're all gonna see each other tomorrow or Wednesday, and we'll get caught up from there. So, all right, thanks for dropping in, guys. Appreciate it.